Okay, so we're going to see about that three-phase voltage source inverter. Three-phase voltage source inverter. See first one. Okay, recapitalize as well as question answer discussion. What is the inverter? What is invert inverter? So what is the inverter? The inverter is convert DC source into the AC source. That's all. DC source into the AC source. And what is the voltage source inverter? What is voltage source inverter? Voltage source inverter means constant voltage, constant output voltage, constant voltage. That is a voltage source. Then another parameter current. So current is a variable with respect to load. Current is variable with respect to load. Okay. The next one, types of some space. Okay. Types of three-phase voltage source inverter. What are the types of three-phase voltage source inverter? It's based on the conduction mode wise. It will go to mode wise. It will go to classify in the two types. Based on the mode wise, it will go to classify in the two types. One, what are the two types means? One is a 180-degree mode, another one is a 120-degree mode. This is a two modes. Okay, this is a two mode. Okay. And next, how many switches are used? How many switches are used on the three-phase voltage source inverter? Okay. How many switches are used on three-phase voltage source inverter? How many switches are used means as similar to the three-phase rectifier, it is used on that six switches are used. Six switches are used. Okay. What is the switching sequence? What is switching sequence? So the switching sequence, it is a top group, or you can say about the positive group. So positive group is the odd number. Positive group is odd number. Odd number you have, see that one, comma 3, comma 5, and then bottom group. Next one is a bottom group. So bottom group is a negative. That is a even number. What is that even number starting? 2. Okay, you can skip the 2. Then what is next? 4. After that, 6. After that, then missing numbers 2. So this is about the positive group and the negative group. Okay. So why do they mention like this is a method? Okay, 1, 3, 5 in top, 1, 4, 2, 4, 6, 2 in bottom. So why do they represent the? Why are they represent like this? Because what is the main purpose means T1 after that T2 is constant place is T2 is conducted, and T2 after that T3 is conducted, and T3 after that T4 is conducted. The constant place of the switches is conducted. That's why we are giving the this is a sequence. T6 after that T1. Okay. What is the angle? Okay, angle difference between T1 switch to T2 switch. What is angle differentiations? So T1 to T2, what is angle? It's a 60 degree. You know, this is 60 degree is common for we will go to it is a common. Okay, common for so three-phase rectifier and inverter also same. Okay, so inverter also same about that one. Then the next one. Here is a top is a 135 and the bottom is a 462 is there. Okay, what is the angle difference between the 1 and the 3? Yeah. What is angle difference between T1 to T3? Similarly, what about that one? T3 to T5 or bottom also 4 to 6 or 6 to 2. It's a what is the angle difference between that one means it is a 120 degree. So it is the angle differentiation is 120 degree. That is also similar for that one three-phase rectifier method. It is also similar. Okay. Then next one. It's a 180 degree mode. What is 180 degree mode conduction? What is 180 degree mode conduction? So 180 degree mode conduction means all switches conduction period It is all switches conduction period is 180. So switch number 1, switch number 2, switch number 3, switch number 4, switch number 5, switch number 6. All switches conduction period is, what about all switches conduction period? It is a 180. So what about 120-degree mode conductions? What about 120-degree conduction mode means all switches are the conduction period is a 121 lane. All switches conduction period is a 121 lane. So why do you go for that 120-degree mode? So why do you go for 120-degree mode? 120-degree mode. So why do you go for that 120-degree mode means due to the drawback. So due to drawback of 180-degree mode. Can you start after the half an hour? Okay, why do you go for that 120-degree mode? So due to drawback of the 180-degree mode. Due to the drawback of the 180-degree mode. Okay, so what is the drawback? What is drawback? So what is the drawback of 180-degree mode means? What is the drawback is there? So the drawback is the short circuit is the problem. So short circuit is the problem. So short circuit of that one problem. What short circuit is the problem? What short circuit? Short circuit problem on 180-degree mode. What is the short circuit problem on 180-degree mode? Okay, particularly RL load condition at 180-degree point, the possibility of the, okay, at 180-degree point, so T1 and T4 possibility to close or possibility to conduct. So if T1 and T4 both also close or conducted means the source, it will go to short circuited. The source, okay, get sorted. So this is about the drawback. This is about the drawback. Okay, how to overcome? That's why 120-degree mode. So this one, what I will go to once again, I will going to tell you here. So I will going to draw the circuit diagram. Then you will going to understand. So circuit diagram of three-phase voltage source inverter. So this circuit diagram is common for 180-degree mode and 180-degree as well as 120-degree. 120-degree mode is a common. What is the circuit diagram? See here, just we will going to draw the source, DC source, and the DC source is DC source is extended plus terminal, minus terminal. Okay, there is a 3 leg you will going to connect here. Then each leg 2 switches. So leg number 1, 2 switches is connected. Then leg number 2, okay, 2 switches are connected. Leg number 3, you will going to connect it on the 2 switches. So 3 leg, that's all. So 3 leg you will going to connect it, and the center of the leg is a base. Center of the leg is a base. So this is a output terminal. You can give the numbers. The top is the numbers. What is that one? 1, 3, 5. Okay, odd numbers. Bottom is the even number. Starting from that one, even number is a 2. You can skip about the 2. What is the next one? 4. Okay, then after that is 6, and the missing number is a 2. That's all. So you will going to give the sequence like this is a method. Then here you will going to connect the load resistance. Yes, you will going to connect it. So this is a method, and a sorted. You will going to sort. So this is a 3-phase inverter, voltage source inverter. Then here, okay, you need to connect the voltmeters. So phase to phase, you will go to, what is the phase number? This is a A phase, this is a B phase, and this is a C phase. There is a 3 phases. Then phase to phase, you will going to connect one voltmeter. So here and here you will going to connect it and measure it. This is a phase to phase value. Similarly, here also you can connect it B to C, AB, BC, then CA. CA means plus terminal is connected to C, then minus terminal is connected to that A. So AB, BC, CA. Okay, this is a phase to phase waveform you will going to measure. Phase to phase waveform of that one. Then base to neutral, so voltmeter connected here and connected to here with respect to the neutral. So this is a neutral point, common ground, so it's a one base. Then second base, so neutral. Then third meter also neutral, so you can connect it to the B base. Where is the B base? Yes. Then where is the C base? You will going to connect. So this is a method to you will going to measure the base to neutral of the value you need to measure. So that's all about that one. And here one thing you will going to know about that one. What is the switch 1 and the switch number 2? So the switch number 1 and switch number 2 is a gap is a 120 degree. 120 degree is a gap between the method. Okay, so that's all about the things, and few more point is there. Then we go to that Word document to discuss. Okay. Okay. So circuit diagram of a three-phase voltage source inverter 180 degree mode and a 120 degree mode is a common one. It is a common. Okay. So any circuit diagram by the differentiation of okay, any circuit diagram differ for 180 degree mode, 120 degree mode means the answer is a no. So no circuit diagram is a differentiation. The circuit diagram is a common about that one. And next, what you want to do? Yeah. So we're going to see. Okay. Then 1 to 2 is a 60 degree. Then 1 to 3 is a 120 degree. If it is a 180 degree mode means the switches is conducted. Every switches is a 180, 180, 180 is conducted. If it is 120 degree mode means all switches is conducted 120, 120, 120 only. Okay. Then what else further point? Yeah. Next one is a delay angle or firing angle. We're going to firing angle. So you will going to apply the angle. You will going to see how to apply the angle. So I will going to make the table. I will going to form the table. Okay. So I will going to write about the serial number. So what is the serial number? There is a mode 1, 2, 3, 4, 5, 6. 6 mode is there. Okay. Fine. Then here. So here is a 180 degree mode. If it is a 180 degree mode, means at a time 3 switches are conducted. 3 switches are conducted. 3 switches are the closed. Every mode is a 3 switch. If it is a 120 degree mode, means every mode is a we will going to conducted about that one 2 switches. Okay, what is the switching sequence? 120 is similar to the rectifier. Similar to the rectifier. Better I will go to last row. Okay. Yes. Similar to rectifier. What is that one rectifier? What is the sequence? 6 1 1 2 2 3 3 4 4 5 5 6. This is a sequence. What about the 120 degree mode? 3 switches are closed. So 5 6 1 6 1 2, then 1 2 3, then 2 3 4 3 4 5 4 5 6. This is the sequence. So this is a switching sequence. This is a switching sequence. Okay. So delete. Yeah. Then angle, we're going to still not see about the angle. So apply the firing angle. So applying the firing, apply firing angle. How to apply the firing angle? So how many switches are there? Switches. Here is a switch. So switches is a T1, T2, then T3, then T4, T5, then T6. There are totally 6 switches. Then angle. So alpha is equal to 0. Firing angle alpha is equal to 0 means you will going to start with the 0. Then 1 to 2, what is the differentiation? 60 degree, 60. Then 2 to 3, same 60. So 60 plus 60. Then 3 to 4, what is the angle differentiation? 60 plus 60 plus 60. Okay, that's all. Then 4 to 5, what is the angle differentiation? 60 degree. So this one plus 60. That's all. Then 5 to 6, what is the angle differentiation? 60 degree. That's all. So this is about the angle differentiations. Alpha is equal to 0. So you will go and write about that one. So it's a 0, 60. Then what is this answer? 120. If you have see that one, 1 and 3 is a 120 degree angle differentiation or not? Yes, 0 and here is a 120. Similarly, 3 and 5 you can see that one. It's a 240. Then what is angle? 240. See that one angle differentiation is 240. Then here, so what is answer? 180. And what is the answer here? So here is missing one more 60. Yes, 60 degree angle differentiation. Yes, 300. That's all. So this is about differentiation. And one more differentiation also available. I will teach you. What is the one more differentiation? You know, the switch, the top switch. What is that one? Top switch. So here is the top of the switch, and here is the bottom of the switch. So bottom of the switch. What is that one? The top switch is what is that one? T1. Okay. Then T3. Then after that T5. So this is the top of the switch. What is the angle of the top switch? 0 degree. Then after that this is angle is what is angle? This is a 120 degree. And this is angle is what is angle? This is about angle is a 240 degree. Okay. This angle is a 240 degree. Then here to here bottom switch. What are the bottom switch? T4. Then after that T6, after that T2. This is the bottom of the switch. Then what is the angle difference between here and here? 180 degree mode. Okay, it will going to start to conduct at 0 to 180. Then here it is a start to conduct from 180 degree. Yes. So it is start to conduct from 180. Then here to here, what is angle differentiation? 180 degree angle differentiation. 180 degree angle. So better I will go to the simple to understand 180, so 120 plus I will go to write about 180. Then here I will going to make it as this 240. I will go to write 240 plus 180. What about the first one? So here is a 0. So 0 plus 180. So this is the bottom of the switch angles. So both also same value. So you will go to another method. You will going to go ahead on that one. So I will going to make that one. Both also this is also one method. So one to another, say angle is 60 degree, 60 degree, 60 degree. This is another method. So 0, 120, 240, and here is a 180 degree phase shift. 180 degree phase shift. Can I get the answer? What is answer? 180. And here what is answer? So 180, 200, 300. Its answer is 300. And what is this answer? You have look at 180, okay, plus 240. Then so 200, 300, 300, 420. See that one? It is exceed the cycle. It will going to exceed the cycle. Then what you want to do? One cycle is what is answer? Is a 360. Then subtract it. Then subtract that one. It will going to subtract on that one. 420 minus 360. What is the answer? The answer is a, okay, here is what is answer one? 340 plus 20, 60 degree. See, both is a matched. Both is a matched. So you will going to write about that one firing angle. So you will going to write what is that one? So 0, 60, 120, 180, 240, 300. So alpha is equal to 0 condition. Alpha is equal to 0 condition. That's all. The same thing you will going to type in MATLAB. So how to you can type in MATLAB means, so I will tell you. Typing the MATLAB, the same method. So 0 divided by 360 multiplied time period. So time period is a 0.02. Why 0.02? So 1 by 50 is equal to 0.02. So this is a method you want to type. So here 60 divided by 360 multiply 0.02. So that's all. So you will going to write. It's alpha is equal to 0. If alpha is equal to 30 degree, what I will do? So if alpha is equal to 0, if I will go to alpha is equal to 30 degree. And what I will do, so put it on 30 here, 30 plus this one. So use the bracket. Over. So this is all was equal to 30. Like you will going to extend it n numbers. Okay, coming to one more differentiation. So what you will do for the difference between the 180 and 120 degree mode. 180 and 120 differentiation you should know. Pulse width with differentiations. Okay, 180 and 120 pulse width differentiations. Okay. Pulse width means only on period. So pulse width means on period. So how 180? So one cycle is 360 divided by 2 is equal to what is the answer? 180. Similarly, pulse width is a maximum percentage. It is a pulse width is what is about that one? It is a percentage. It is a percentage. 100 percentage. Then 100 divided by 2 is equal to what is answer? It is answer is 50. Then here you will going to coming to here. So 360 divided by 3 is equal to what is answer? 120. Then here 100 divided by 3 is equal to what is the percentage? 33.33 percentage. So 33.33. If you're going to go for that 50 percentage means that is a 180 degree mode. 33.33 means if you're going to do that is about the 120 degree mode. So that's all about the major concept. So this concept is behind about 180 degree mode and 120 degree mode of the three-phase voltage source inverter. Okay, so this is a differentiation about the working. So three switches is a mode conducted, two switches only each mode conducted, and this is a firing angle. So this is a firing angle of that one to another. This 60 degree interval. So I have a each one is a 60 is increase, or you will go to or you will go to or. So either this method you can go or this method you can go. Okay, so just you can go. So only change the firing angle. Sorry, pulse width is change 180 degree mode into the 120 degree mode in the MATLAB simulation. It will go to simply will go to complete it. Yes, and the last one more. Yes. So three-phase system. So three-phase systems. Okay, you will going to see about that one. Waveforms. So waveform you want to know. So what is a waveform? I said easy to remember waveform. 1 1 0 minus 1 minus 1. So this is one type of the waveform. And another waveform, what is that one? 1 to 1 and minus 1 minus 2 minus 1. This is another type of the waveform. Then 1 1 0 minus 1 means this is a 180 degree mode. Always we are consider 180 degree mode. So 1 1 1 1 means phase. So V phase to phase PP. Then here is what is that one? PP is over means another waveform is a phase to neutral. Okay. So the phase to neutral. So what are the that one PP? So VAB, BC, CA. Then here AN, BN, then CN. Okay. So this is a waveform. Then here is a 120 degree mode. 120 degree mode means just opposite the same waveform. The waveform is a constant. Then VPP in stuff. Just you will going to copy it. Okay. I will going to do the colors. So copy it and paste it. And this is a waveform. Okay, this same waveform. Okay, you can do one color. Okay, green color, copy and paste. This is a only differentiations. The waveform wise is a difference between the 180 degree mode and 120 degree mode. So that's all about the 180 degree mode and 120 degree modes. So now what you want to do, just you will going to watch about the videos, and you will going to see about, yes. So I will going to explain you step by step of the three-phase voltage source inverter here. So just you will going to watch it. Circuit diagram is common. Okay, load is there, and the phase to phase of the voltmeter, and the phase to neutral of the voltmeter is connected. Okay, phase to neutral of the voltmeter is connected. Then you will going to see. Then pulse width only differentiations. So load error testing purpose, I'm using the two loads. Even one more simulation I have developed. Both simulation it will going to teach you. Whatever I have said, the same thing I will going to give the firing angle. See the firing angle. So either this method you can proceed or another method you will going to proceed. Yes. So here you will going to stop and then look it. So pulse with the first one. What is that one I want to give? See, period is at 0.02. Why? 1 by 50 is equal to 0.02. Pulse width is at 50. If pulse width is 50 means 180 degree more. Okay. What is the P1? Firing angle is 0. Over. What is second one? Second one is I need to give for that one 60 degree. 60 degree I need to give. Otherwise, what I will going to give? So directly I will going to give 240 plus 180 subtract 360. I will going to give you. So like about that all the pulses I will going to give on that one. Okay. So waveform also I have what I have explained, the same thing I will going to explain you waveform. See that one here is a 11011. If it is 11011 means it is called a pace to pace. So here 1 to 1, another one is a -1, -2, -1, no 0. So it is a pace to neutral. Another one is a pulse value also. I will going to show you P1 to P6. That is also I will going to show you. So and they explain you what is a pulse wise in the mode diagram. I'm explained you. Okay. So now I will going to change that one here. If 50 inch of 83.33 120 degree mode. So you will going to do means you will going to get. So just you will going to change it. So pulse width is changed into 33.33. See the waveform, it is a coming on that one. Okay, so you will going to watch this video. That's all. So this is a point I will going to